In this equation, we have the mass of 2 kilos goes up to a 30-degree inclined plane. We also know that at point A, the velocity A is going to be 2 meters per second. Then it says the mass goes up and returns to a point A with a velocity of 1.1 meters per second. So the first question is find the work done by the friction force. Okay, so we know a few things. We know the work of the friction equals the delta K, which represents the kinetic energy, minus the work on the weight, which comes from this formula. So based on this formula, we can just plug in values into here. So you got 1/2 multiplied by 2 times 1.1 squared minus 1/2 times 2 times 2 squared. So that should give us a work of the friction of negative 3.79 joules. In part B, we're given that m sub k equals 0.3 and the friction is m sub k times the normal force. And they're asking what the distance that can travel the mass until the velocity is 0. So we're gonna do the following. We're gonna do a representation right here. We have the two masses, one right here and one right here. In this case, these two masses are the same because it's the first one that is just moving, and that's where we represent the displacement into delta S right here. We also know other values such as theta, which is 30 degrees. We also know y1 is this part and y2 is the second one. So we know that y1 minus y2 is going to be negative. If we pay attention to this right here. So the main goal is to find for delta S, which is the distance or the displacement. So we gotta start from simple algebra, being that the work equals the delta K. We can expand this into the work of weight plus the work of the friction equals delta K, which is expanded into this. As we proceed with the equation, we can say that the work of the weight is equal to this. And that's why it was important to say that y1 minus y2 is going to be negative because it's going to come into effect right here. It's going to come handy. Next thing we're going to do is replace the work of the friction into m sub k times the normal force times the displacement, so this whole thing right here. And that's going to be equal to whatever we have left off from the top. Then we can replace the y1 minus y2 into the magnitude of the displacement and sine of theta. Therefore, we can continue with the equation and we can put in the values. In this case, it's sine because the y1 minus y2 is going to be this side right here, and the opposite of the angle is going to be sine. Now on the other one, we have that 0.3 times mg times cosine of theta times the magnitude of the displacement. And that's going to be equal to negative 4. So in this case, you got negative, negative, negative. So we can also, to make it just easier, we can change it to positive. It's going to be the same thing. Therefore, we're just gonna pretty much solve for delta S. So we continue doing the algebra. We can group these together and just plug in the values. Then as we proceed, we're gonna end up having delta S equals 0.3 meters per second in the upper direction. And that's the final answer.